everyone for joining this session. Sorry about my voice, I'm not feeling well today, so you might have to bear some coughing or sneezing. So sorry about that. Okay, so my name is Owais Zahid. I'm a lead developer at Autodesk. Okay, I need to be here, so sorry for that. Really excited to be here. Okay, so let's start. So I will start this talk with a simple statement. World is changing. It is an undeniable fact that we are living in a world of constant change. From global socio-political landscape to individual preferences, all are in a constant state of change. So this change is actually impacting the way we design things. So we are building more sustainable and eco-friendly buildings than before. We are moving away from gas-guzzling cars to more environmentally friendly alternatives. And we have revolutionized the way we travel. Probably we have actually made a wrong turn, so this is not a good example. So let's ignore that. It's not about the buildings and the vehicles. Everything is evolving. So this is also translating in the way we design applications and systems. So with increased connectivity and all right. Okay, so with increased connectivity and the computing power, more and more applications are utilizing cloud computing. And there is a major shift from monolith architecture to more distributed microservice-based architecture. All of these things are actually have a profound effect on the way we develop web and mobile applications. So today, we will discuss one such change which is influencing or will influence you in future the way you design your web and mobile applications. Folks, today we will discuss about HTTP2 and how you can create high-performance applications using HTTP2. So this is the agenda for this talk. So we will start with building our understanding of HTTP2. Then we will look at some of the key features, followed by a demo session. This is a dev conference, so I have to bring code into it. So yeah, we'll look at some of the key features of HTTP2 in action, and then we'll do some code walkthrough. Next up is the migration strategies that will answer some of your questions that if you want to use HTTP2 in your existing applications, how you can do that. And last but not the least is we will look at the application performance from a broader perspective, and then we will see how HTTP2 fits in. And then in the end, we'll open the floor for the Q&A. So let's get to it so that we have some time here to have two-way communication. So, and all right, let's jump into it. HTTP2. So HTTP2, you guys can hear me, right? Yes. Okay. So HTTP2 is the latest revision of HTTP, which is Hypertext Transfer Protocol. Quick revision, HTTP is an application layer protocol of the TCP/IP network stack. It is sort of a protocol of choice for information distribution and communication on a little known thing called internet. So HTTP2 is largely based on the work Google did in prior to it in the PD protocol, and the specifications were published 2 years ago in May 2015. So it was only last year, 2016, that people started talking about. The main reason was like more and more applications, more and more browsers, tools, web servers, proxies, they all started implementing this specification. Some of the examples are Apache, Tomcat, GoSQL library, Hyper, Carry. There is a link here. You can check the bigger list. So these are like a good indication that the HTTP2 is growing. Let me share another stats with you. So this is the graph I took from W3 Tech. So this graph is actually showing a steady increase in the content served from HTTP2 servers. So this graph is also indicating that actually we are moving from early adopter stage to early majority stage. So that is why it is a really exciting time to talk about HTTP. All right, so let's look at some of the key features. Okay, it's just running. Okay, first up is binary protocol. It is not a feature per se, but it is a big difference from the prior revisions, which were textual in nature. From end user point of view, this doesn't matter a lot, but when it comes to parsing data, it makes a huge difference. So we don't need to, unlike the textual counterparts, so we don't need to worry about the white spacing, the capitalization, end of line, and etc. That makes the parsing really fast and efficient. Apart from the parsing, it also optimizes the transportation of it. We'll talk about these two things later on. So before I discuss the next feature, let's talk about something. So let's look at how HTTP handles client-server communication. So in order to send a request to server, I need to open an HTTP connection and then do a TCP handshake. As a client, you send a request to server, server will acknowledge, and then you acknowledge the acknowledgement of the server. So this is called three-way handshaking or TCP handshaking. So if you sort of flash back to HTTP 1, so each request needs to open a connection, then do a handshaking, perform action, and then close the connection. So even with or without multiple connection, this was an arduous process because there is a cost associated with all of these activities. So for simpleton web applications, the HTTP worked. But as application grew bigger, people quickly realized the limitation. So then things like keep alive header come, and then later on the pool of persistent connections to fix this issue. But even with, so that actually solved that problem, but again, applications outgrown and then became more complicated and more demanding. So the other problems surfaced, and the most common one that the web developers, as we always talk about, is the head of line problem. This is probably the best analogy I can have for head of line blocking. So it's like if you went to a grocery store or some supermarket, especially on the weekend, and then this is what you are getting at the checkout counter. So this is, you can follow the same analogy on what's going on with a head of line block. So if one request is taking more time, then the rest of the requests are sort of queuing up. Even with multiple counters or multiple connections, you are still getting queued up. So this was one of the sort of the biggest performance drawbacks of HTTP 1. Even with the introduction of pipelining, head of line was an issue. So it's not just about head of line. Head of line is sort of a headline issue, but apart from that, there was another thing. There is another thing, which is TCP slow start. So let me explain that a bit. So TCP slow start is actually when your request goes into on the network in the form of packets. So what TCP do is actually it starts with like a small bundle of packets, but default is 10, and then it increases the size of the window and eventually come up with the optimal size of packets that will send. So if you have multiple connections, then all the connections will start slow. So even they are persistent connections or non-persistent connections, they will all start slow. So the argument that more is better is not valid here. So we talked about two problems: head of line, TCP slow start, because we have multiple connections. So HTTP to actually address this issue by introducing multiplexing. So instead of having multiple connections, you have a single connection per origin, and requests and responses are handled asynchronously. Let me give you an example. So client is sending 3 requests to serve, and the response of the request 2 and 3 is coming before request 1. This situation is possible because of multiplexing. So you are not getting blocked by the first request. So the question is how it is working behind the scene. So in order to answer this thing, we need to understand 2 key concepts that HTTP 2 is introducing. One is called frame and the other one is called stream. So let's talk about the frame. So frame is a basic unit of HTTP 2. It is the smallest unit of communication. So for example, so your request is actually divided into frames. For request and response, the frames are data and header frames. But there are other type of frames as well, like setting frame, window frame, push promise frame. But these are all related to other features of HTTP. So yeah, and the second thing is the stream. So a stream is, you can say stream as like a bi-directional independent sort of sequence of frames. And each connection can have more than one component streams, and each stream you can identify unique by an identifier, which is 31-bit unsigned integer. So this is how your communication will look like at the protocol level. You have a connection, and then a connection will have n number of streams, and then each stream the data is flowing back and forth. So that is why it is possible to handle these scenarios. So this is the proper solution of head of line blocking. And since this is just one connection, so the TCP slow start will only impact you once. Alright, so limitations of HTTP 1 actually pushed us to do smart workarounds, and then the smart workarounds later became the practices. So with HTTP 2, there is a need to actually revisit all the practices and like just reevaluate the viability of it. Let me share some of them. Domain sharding. The domain sharding is mainly done to actually allow an application to have more connections than you have the designated port of. So in on normal browser, let's say Chrome, you can have like 6 maximum connections. So if you do domain sharding, and you have like you spread your application across 2 domains, then you can have like 12 connections. But with HTTP 2, this becomes more of an end-type network because there is no need. There is just one connection, and there must be a really, really good reason that I really like to hear to have this thing now. Again, we should not sort of confuse domain sharding with the way we deploy our application on cloud. Because when we deploy our application on cloud, the application is mirrored across a lot of data centers. And based on the proximity of your client, that particular data center is used. But the definition of domain sharding is different. Domain sharding is solely done for the purpose of having multiple connections, more than the designated connections, which with HTTP2 is not needed. Second is sprites, CSS sprites and Vulcanize. Let me talk about these two together. So both of them are actually sort of combining the resources into a single unit. So there is 2 problems with these 2 approaches. One is this thing is not cache friendly. So if one of the resources is sort of updating, you need to invalidate the whole bigger unit. And second thing is that you tend to send more information to the on the client than the probably client don't need. Like you're just sending all the images that client don't need at that point of time. So there is a need to actually reevaluate these things. With some of the features of HTTP2, it's just going really fast ahead of me for some reason. I'm sorry. Okay. So with HTTP features, we need to reevaluate whether we need these things. All right. So header compression. One of the sort of the less talked about limitations of HTTP1 is the inability to actually compress the header fields, which is actually sort of contributing the utilization of the bandwidth. So, but with HTTP2, since we are dividing it, just let me go back. So since we are dividing the request into header and data frames, then it is easy for us to compress the headers as well. So, yeah. So, for that, HTTP2 introduces a new algorithm, extract, which is based on Hoffman coding with an ability to use a lookup table. A lookup table is at the connection level, so multiple requests can utilize the same lookup table. So that makes the compression really fast and really efficient. So again, it's all about putting less data on the wire. So this is cool. All right. So last up is the server push. Server push is sort of one of the most talked about features of HTTP for some reason. Okay, so this is the normal flow. In the normal flow, you are actually, for example, you are fetching the HTML, you are getting the HTML, and then you are then sort of parsing it. You are trying to create a DOM tree for it, and then once you see that there is a need to fetch the sort of a dependent resource, you are fetching it, and then you will get the CSS, and then you will create a CSS object model, and then finally you will create a dependent tree. So we can improve this process by using server push. So in server push, we actually normally return the thing that client is asking, but we are also sort of saying, okay, you might need this one as well. So hey, take it. So that's what server push is doing. So client just asks for HTML, and then server being really generous, just sending the CSS as well. So server push sort of in some scenarios can make a difference, but we'll see later in some scenarios it can create some issues. Alright, so alright, so enough talk. Let's see a few things in action. So I will start with showing some of the samples that I found really useful, and so these are some of the samples of that the Go community created. So Go language community is one of the early adopters of HTTP, and they have a really comprehensive support of HTTP. So if you need to know more about their HTTP2 support, there is a link to the HTTP2 package. You can go and check it out. So they have many samples here. So I will share two of them in this talk. So let's start with the Go for time. So this is more of a simple load test. And you can, it's just to compare head-on the difference between HTTP2 and HTTP1. So, alright, so let's see first how things are going with, alright, let me open the, so let me load the same page with HTTP1. So this whole Gopher tile is actually comprises of small images, tiles. So yeah, it's loading. Will finish eventually. So yeah, so it's taking like 13 seconds to load this simple page, and you can see on the left side all the network calls. Which is happening. Alright, so again, so a protocol, you can see that it's HTTP1. Connection ID is something that you can see like there are 5, 6 connections repeatedly used, and then again, this is where we are seeing all the queuing up happen, like it's just happening. So, and then the outcome of it is that in order to actually load the whole page, it took around 13 seconds. Let's see the same thing in HTTP2 with the same latency. Okay, I don't know about you guys, but this looks fast, right? It's 2 seconds. So yeah, it looks fast. So yeah, so few things to notice. Protocol is a H2. The people who have used Speedy before, they kind of sort of familiar with like seeing Speedy here. Important thing to note is the connection ID. It's just using the same connection ID. So there is just one connection for audition. And important thing here is that there is like most of it's all sort of started at the same time, but you can still see some level of queuing. The main reason for it is like there is a limit to the maximum concurrent streams that you can have on a connection. By default it's 100, but you can configure it to be as many as you want, but yeah, by default it's 100. So if you have more than 100 requests, some of them will be, but still, even with that limitation, this is really possible. All right, so this sort of this demo is more about talking about the multiplexing aspect of HTTP. Let's look at another sample. This is server push. Alright, so let's look at the same thing. So first load it in just a normal flow, the HTTP only. So I mean nothing really fancy going on here. It's the normal flow. That's how the HTML pages load. So and it's taking around like 2.8 seconds. Let's see how server push works. Okay, not a huge difference, but still better. So loading is like now it's 1.6 seconds. But the important thing to note here is that all the resources, the CSS and the JS files, they are in the initiator. You can see the push. So this is sort of an indication that these resources are pushed. So what is happening behind the scene is that when you are actually sending a request and you are getting the response, and server is actually sending what is called a push promises. So server is actually sending 4 push promises on a separate stream, not on the same stream. And then client accepts that promise, and then you server start sending data to you, and then this data is actually saved on the client side. You can say it's saved on a push cache, or it's somewhere in the memory. It's not in the HTTP cache. It only goes into the HTTP cache once the browser actually make a formal request for it. So this is the key difference. We'll talk about this caching thing in bit detail just in a few minutes. Okay, so these are the Go language samples, but it's just not. Just so you guys don't think that I'm lazy, I'm just showing you the samples from some other website. I actually spent some time in created my own samples. So this is like a small application I created. So I created 2 test scenarios. The main purpose of creating these things by myself is to have sort of a hands-on understanding of the features, and to sort of better understand what HTTP2 is offering. So let's look at the samples, and then we will go to the code. So again, this one is something sort of related to the Gopher sample that we saw earlier, but this is more of like you can set different scenarios, and then I'm actually fetching the JSON. So the point is to actually fetch the random quotations of some famous authors. On the backend, I'm using Express, Node Express. On front end, it's just plain HTML with minimal jQuery. So I mean, you can see it's not really fancy. So, all right. So okay. So let me just try to fetch it on using HTTP2. So it's now starting to fetch the quotation. Working, they are showing. Okay, so it took around like 8.6 seconds to do that. So I have another server which is running on HTTP 1, and let's try to do the same thing there. So, all right. Maybe we can all go and have a cup and then come back and enter. Just imagine what would have happened if I just select the 300 items. We'll go to that lunch directly. Okay, so it's coding. So again, it is the same code. I'm not making any changes. It's just the same code. The only difference between them is the protocol. So the difference is huge. So we'll later talk about, we will talk about in detail when we will do the sort of a quick analysis of the performance. I mean, this is huge. All right, so this is some sort of similar to the earlier sample, but the other sample is sort of interesting, which actually this thing actually, I want to experiment the server push with the caching, because that is sort of a combination a lot of people are struggling. Just to give you sort of a context of it. So first, in a normal push, so this caching is actually is fetching the travel logs. So on the server side, we have some travel logs. Travel logs is like some detail of your recent travel and some pictures. So if I fetch it normally, then so this is from my recent trip to Portugal. Great city, Portugal. Okay. So you can see that these are the images. So I am actually loading the images. So the thing is, these images are caching. So if I fetch it again, see what will happen. Just focus on the net, on the log. Now the server is only fetching the HTML. It's not actually requesting for the images, because images are already cached. There is no need to fetch it again. This is where things can get sort of problematic with the server push. Let's clear everything so that we start fresh. Alright, so server push. Great. First time it worked like a charm. That's how I expect it to work. It should give me the images as well, because I'm pushing it. But see what will happen the next time. Alright, it's just a one call. Yeah, but behind the scene, server is actually trying to push the data again. The reason how I know it is, you can check the log. So I did that the second time, so I'm logging it, so it's actually pushing the resources again. So this is not ideal, because you are this is not an optimal solution, because you are putting more data on the wire, which eventually will be discarded by the user, by the client. So one more thing that I can share with you guys is that if you need to know more about like how this packets and everything is working, Chrome has like an awesome support. So you can go into the net internals, you can go to the HTTP2, you can go to, because this is my server, and when you select it, you see all the logs. So here you can actually see all the stream level activity happening and all the frames exchanging. So what happens behind the scene, that if client already have something and you are trying to push, then the ideal behavior is that the client will reject your promise. It will set a reset stream free. But the problem which is happening is that the server implementations that we have, and I tried multiple server implementations. I use Caddy, I use Golang, I use Node. All are actually not handling this thing well. So this is one limitation. So if something is sort of rejecting your promise, then your code should get some sort of notification so that you can be a bit smart about the things that you are pushing. This is not happening right now. So server push is still sort of a hit and miss thing. And the main problem that I saw with the push sort of contract is that when you create a connection, this is where the setting frames are exchanged between client and server, and this is where you actually decide whether to allow the push notification or not. But it would have been great if we can do sort of this this contract at the stream level, so that I know whether I can push or not. So some of the sort of a workarounds that we can do is to either use service workers, and because you can filter few things, and then maybe if you have something in the cache already, then you can add some custom headers to your request, or maybe you can have some query parameters, so that server when server look at your request, it can decide whether to push it or not. But again, that needs some work, so you need to do some middle layer work. So recently there is a really good blog that Jake uploaded on HTTP2 push. He looked at the HTTP2 push from sort of a different angle. I highly recommend you guys to go to this thing. So he actually used push on multiple browsers and see how the push works when you are calling fetch, when you are calling, when you are using prefetch, or you are just doing an async. All right, so for the code is open. It's on GitHub. All the code is here. You guys can check it out. I tried to add some details here so you can set it up and use so I tried to add all the references that I use to gather my knowledge of HTTP2, so it might be helpful for you guys as well. So let's say, if I use any reference, I actually mention it in my comments. So if you need to know the details like why I'm doing something, you can always find a reference on like why I'm doing some workarounds. So it's a simple code base. If you are sort of, if you just want to know about HTTP and see how whether it works for you and how you can use it, I mean you can check it out. For server push, it's a simple code. You can see here. So if push is enabled on your connection, so request or push it is true, and then you can push things. So it's just a quick code. So all right, so I think how much time we have? About 10 minutes. Oh, or 10 minutes is all right. Okay, so I think by now you must have sort of understand the benefits of HTTP. So now the question is like, how can we use it? How can we start using it? So if you are planning to work on a new project, or you are just starting a new project, then I would highly recommend you to start using it from scratch. That will save your time for the migration, and will also like you don't have to do all the hacks that we talk about. You can make things simple. But what will happen if you are actually working on any existing application? What options you have? So there are two strategies that we can use. One is the fast move, is like if you are working on some personal projects or some simple projects, in which like it's a low risk project. With low risk project is like there is less sort of security checks and audits and all the enterprise or the things on it, so risk is low. So all you have to do is to just upgrade your servers and variables, or you can use something like Caddy that can add it in front of your server as a proxy, and then use your servers as it is. So, and optionally you can start removing the bundles and sprites and make things simple. That will make things easy to cache. But let's say most of us are working on some medium or large projects for maybe an enterprise project. So probably this is not a good strategy for the big projects. So for that, it's more about the incremental move. For incremental move, you need to start with some low-hanging fruits. So I think you should start with upgrading the CDNs or the static servers, because there is sort of less risk there that will not sort of impact a lot of things. And then incrementally upgrade the client-facing servers, how many you have. And you can also start reconciling the servers if you have created the servers for the sole purpose of domain sharding. Just destroy it. And optionally, you can reevaluate the bundling as well. The reason I'm saying no bundling and saying reevaluating is that for large projects, you might have many resources. Maybe you have like hundreds or 200 JS files or CSS files. If you just remove the bundles, that will just increase the number of files you have. And we have seen in the demos, like there is a limit to the concurrent streams. So probably the ideal solution is to like go halfway and like create sort of bundles, but like not a big bundle that contain everything. Just smartly sort of chop things down. This is where I think the new functionality in the Chrome, which is on Chrome Canary but not on the actual Chrome, is that it can show you the code coverage. So if you have any JS files or CSS files on your page, it can show that how much of that file you are actually using. So if you have bundles, you can use that code coverage to see, hey, I need the whole bundle, maybe I can just chop it like this so that I can utilize it properly. So Sinthan, is he here? No. Okay. So we talked about webpacks. So I mean, most of us are using webpacks. So webpacks do the same thing. It actually just combine things, bundle it into static contents. So the good news for the webpack users, they have this aggressive splitting plugin, so you can split your bundle into smaller chunks, which will sort of which can be, or if you really need to customize this thing, so you can create your own custom plugins. All right, impact of HTTP on performance. So performance is applicated. So performance and speed, these are sort of interrelated terms. More often than not, the success of the application relies on the response time, or at least the perception of the response time. So let me share this graph. So this graph is from Elias Grigorev's book, High Performance Browser Networking. I highly recommend that book if you are interested in understanding the application performance. So this graph is actually talking about the delay and the perception of it. So if you want to create a high performance application, you need to be here somewhere. I mean, it's fine to be there, but this is like sort of a target, like around 1 second, 1.5 is like good enough. Anything like this, all right. So in order to do that, we need to take into consideration all the aspects of client-server interaction. So with that, I mean, we need to look at the hardware dependency. This is really important for mobile applications, like how much time your hardware is taking to register a few things, like your touch event. How much time it is taking to actually register that, if you're creating some application with accessibility support, like how much time your screen reader is taking to like capture that thing and giving you the actual view so that you can send it to server. The network condition, what type of network you are using, 4G, LTE, high speed LAN. Performance varies drastically on network condition. So the problem with network condition is like you cannot do much about it. So, but we can do few things to sort of better prepare for this network sort of inconsistency. I mean, you can test it by throttling your application properly just to see how it works. You can use some sort of prefetching mechanisms or some offline support so that if application is really down, if it's using a network which is not really good, this user can still see something, because it's all about giving user something so that user can perceive that something is happening. So it's all about engaging user. Third thing is the server response time. How much time the server is taking to actually process your request. So if the response time is like 1 second, 2 seconds, so we need to do something about it. Either we can reevaluate the whole infrastructure that we are using for the server. Maybe we need more servers. Maybe we need to smartly move the data center to be be more close to the user. Or if you are sort of in some applications, it is expected for the server to take more time. Let's say if you are doing some big data queries or whole app queries, it will take like few seconds to complete things. So for that, you need to reevaluate your workflow. So instead of showing the client that okay, it's loading, maybe you can go for a push notification. So that again, so we need to be smart about it. Rendering. Rendering is like we need to make sure that when user is actually loading a page, the first page load is as fast as possible. We can do a lot of things here. We can clean up the bundles. We can lazy load the things that we don't need, and we can make some of the resources inline, like CSS that we know is crucial for the critical part of it. So you can have some of the CSS and JS loaded. Some of the things that can wait, we can load later on. And so this is where HTTP2 can come into the picture. It can help you like with multiplexing and server push. So again, application performance is sort of a bigger topic. So let me try to just sum it up, this whole thing. Will HTTP2 improve the performance? Yes. Will it sort of cure all your performance headaches or global warming? But again, like coming back to the statement that I started with, like the world is changing and your demands are escalating. So in this business, every bit counts. So an HTTP is one thing that you cannot ignore. But it doesn't mean that you can just stay happy with HTTP2. You also need to do other things. Yeah. Thank you. That's about it. I think we have time for questions, right? Hello. Okay, I think are we done, or we can do some questions? Or
we are all from time actually, so this is lunch break, but I think people can feel free to meet with you during the lunch, have a discussion.
Cool. Okay, yeah, that's fine. Okay, thank you so much.